Okay, folks, let's take a look at now this idea of statistics. Let's connect what we've learned about probability to this concept of statistics that you hear thrown around all the time in the news and see in the newspapers. So statistics is data collected from real life events or studies. By collecting statistics, we can determine probabilities that will help predict future events. And that's the purpose of our probability as well. Things like sports betting. Statistics give us the odds and we play the odds. Things like election polls. Statistics give us what the percentage of popularity is, what the probability is somebody may be elected. Insurance rates. Data collected determines rates depending on the percentage or the probability somebody's going to be in an accident based on the data collected about people that are in accidents. Weather. Weather patterns. Data collected on patterns give us statistics about the likelihood of a snowstorm hitting us and us getting a snow day. And surveys are where we get our data, or I shouldn't say that. Surveys give us information that allow us to predict how something might happen. What I mean is, if we survey 150 students and we get the following answers, 65 out of 150 like to watch hockey, 45 want to watch football, 30 watch baseball, 10 prefer not to watch any sports at all. Determine the probability that a person will prefer to watch hockey. So the probability of somebody preferring to watch hockey is my number that I've collected in my experiment, in my survey, 65 out of the total respondents. So 65 out of 150. And we often see our survey data change to percent. So 65 divided by 150 is 43.3%. If I want to know the probability of those that prefer to watch baseball, well, it's similar. So 30 reported they preferred to watch baseball out of a total of 150, and that would be about, or that would be 20%. So we can take then a survey result and we can expand that to see what would likely happen in a much larger or much smaller group. In this case, example B, I'm talking about a larger group of 1,000. So based on the results above, if a group had 1,000 people, how many would you expect to prefer to watch football? So they reported 45 out of 150 preferred football. So that came from our survey. And I want to know how many people out of 1,000 are going to like football. So this is this unknown group of people out in the real world. So we take our survey information and our group information and we make a little equation. And from our equation, we solve by rearranging the equation. So instead of dividing by 150, I move it over and multiply. And the same thing with the 1,000. Instead of dividing by 1,000, I move it over here and multiply, and I get something that looks like this. 45 times 1,000 is 45,000. You may have heard of this called before cross multiplying. Same thing. And to figure out x, then instead of multiplying by 150, I move it over to the other side, or I do the opposite, and I divide by 150. So that means in 1,000 people, you would expect 300 people to prefer football. All right. If a random student was selected from a group, what is the probability that the student does not prefer to watch hockey? So the probability that they're not interested in hockey. That might be quite a few people because there are a lot of other sports listed. So this is one where it might be easier to do the opposite. So take the 1 and minus the probability of those that prefer hockey. So I know from above that 43.3% preferred hockey. Now I can't take 1 and subtract 43.3. That's too big a number. Remember that a percent is just an expression of a decimal. So I want to make sure that I change it to a decimal to do my subtracting. So that gives me 0.567. And then if you would like, it would probably make more sense to think of that in terms of 56.7% that do not want to watch hockey. Okay, so you're going to try a few questions like this, and then we'll go on from there.